Hello, what I'm going to show you today is the Glentek vector drive, how to set it up and install it. Basically, this is the Glentek vector drive. It replaces any inverter or vector drive for Fadal machines. 5 horsepower, 10 horsepower, 15 horsepower, 20 horsepower motors. If the motor has an encoder or if the motor does not have an encoder, it also will do rigid tapping also. So this basically will handle any inverter or vector drive replacement that you need to get done. What you need to get to set this up, if you don't order it set up already, is a programming box that is our basic USB memory product, but it can be reprogrammed so that you can load and configure all these drive configurations, and I'll show you how that works. And I'll basically be going over the instruction manual. It's very simple to use. You load the configuration drive file. Once that's loaded, that's pretty much it. If it's a rigid tapping machine, you may need to balance the RPM. Other than that, that is all that needs to be done. So you put the drive in. You leave these 2 screws in so you can hold the drive in place. Now to hook it up everything should be labeled before you took it out. It should be labeled T1, 2, and 3. L1, 2, and 3. It's labeled here on the drive, T1, 2, and 3, L1, 2, and 3. So this is input, this is output. The 2 resistor wires for the regen usually aren't labeled, and they'll be going into R1 and R2. So you want to clean up the wires before you put them in. So you can start anywhere. So feed these in. And then, so this one is just an inverter. It has no encoder. Above each connector, it's labeled and tells you what they are. But basically, there's only the connectors will only go one place. So this one can only go here. The other possibility would be the wye-delta, but this one will be above this one. And this is the encoder input, encoder output, and when it's a wye-delta. And I'll show you an example of that later on. But basically that's it. We've connected the vector drive and we'll program it to become an inverter without an encoder. Okay, so the next step is we'll plug this into the vector drive, and we'll reprogram it to become a 10 horsepower encoderless drive. Turn the machine on. You'll see a C here on the drive. The C means that the outputs are clamped, so the drive is off. So whenever the drive is off, you'll see the C. So to program it, you select config drive. We'll find a 10 horsepower no encoder, which is what this machine is. Select it and press start. That's it. So we're done. We'll go ahead and turn the machine off. We'll now wait for the C to go away and go blank before we turn on the machine and test it. Go. Okay, we've installed the drive, set up the parameters, and we're going to try it out. Turn on the machine. Cold start. Go ahead and manual data. S5000, 500. Turn it on. Voila. We've replaced our vector drive. That's it. So I want to show you another installation. This is a vector drive with encoder feedback coming from the spindle motor, and the output's going to the access cards. It also has wye-delta relays which go here, and you can see the wye-delta's over here. So this is basically a wye-delta rigid tap encoder vector setup. So you would configure this doing the same way. You would select configure drive, load the configuration, turn off the machine, wait till the C disappears, turn it back on, and now I want to show you what the next step would be. So when it's a rigid tap machine, you should balance the RPM so that it's the same with an M3 and an M4. I'm in MDI. I have a long Cat5 cable going to the back of the drive. So what you do is basically type a spindle speed 300 M3 for one direction. On the display should be the motor's RPM. So right now it's a direct drive system, so it's 300 RPM. So that looks good. Then you enter in the other opposite direction, and what you want to do is you want these numbers to be the same in M3 and M4. If it wasn't, you can come in here and basically raise or lower the millivolts, and the RPM will go up or down to each press. So what you want to do is increase or decrease the millivolt balance until they are balanced. When they are balanced, you press exit, you stop the spindle, and then you say yes and save those changes. And that's it for a rigid tap vector drive. Load the parameters, set the balance, you're done. It's that easy.